Hi everyone, in this video I want to talk about multiplying and dividing radicals. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, here's the fun question for the day. If you could only pick 3 hobbies that you could do for the rest of your life, which would you pick? Okay, so we have multiplying basically 2 binomials that all have a root involved. I just recorded the adding and subtracting video. Adding and subtracting require like terms. However, multiplying does not. So I can actually just treat this as if it was, say, like a first, outer, inner, last, FOIL question like this. So I could, just do the x squared and 3x, that sort of process with. One thing to note before we start is there's sort of a product property with radicals, and that is that the nth root of a times the nth root of b, nth meaning just like whatever number, the third root, the fifth root, the fourth root, is the same thing as that same root of a times b. So you could take the square root of each piece, of each factor, multiply them, and it would be the same answer as square rooting or cube rooting or third rooting or whatever, nth rooting the product of those two numbers. So same thing here. There's a quotient property which says if you take the nth root of a over nth root of b separated, once again, it would be the same thing as them square rooting or cube rooting, nth rooting the a over the b. So that is helpful in certain situations. The product property helps us do this first one. So if I have 2 binomials, I have to basically multiply every combination of factors together. So a root 2 times a negative 3 root 3 would be negative 3 root 6. Then I would get 4 root 10. Once I get a 10, like an even number that's a little higher, I start to think, ooh, could that get simplified any further? That one can't, because you can't take a perfect square out of 10, other than 1. Okay, now these together. So we'll have negative 3 root 15, and then plus 4. Root 5 times itself is just 5. So that right there would be like adding 20. So this would be 20. So I'm going to bring the other ones down, and I'm going to look and see if any of the factors match. I don't see anything matching, and I don't see anything else that could be further simplified. So that must be my answer. I cannot combine the 6, the 10, the 15. They are not like terms, as we saw in the adding and subtracting video. And so I must just leave the answer like that. Now, for dividing is kind of similar to what we just did. But, okay, we can't have a square root in a denominator. That's something to remember. Let's say I had a problem like 5 over root 7. I can't leave that root 7 in the denominator. So in order to get rid of it, I have to multiply by, I have to rationalize the denominator, that's what it's called, by multiplying the root 7 on top and bottom, and multiplying straight across. So 5 root 7, and then on the bottom, it's just 7, because it would be the square root of 49. Basically, you just drop the root sign, and that's just 7. So that trick is helpful when I have, remember my problem was like this. That was just a single root on the bottom. But this is a lot messier here where we have, multiple terms. There's a 2 in front of this root. There's a root down here, but there's a 3 with it. So there's a trick, and that is to use what's called the conjugate of the bottom. Okay, the conjugate of that denominator. The conjugate of a plus root b is just a minus root b. Conjugate. This is the fancy, clever trick to getting rid of a root. I can't just multiply by root 2 over root 2 here, because if I multiplied that in, I'd get 3 root 2 and I'd still have a root on the bottom, and that's no good. So the way in which this works is you take the bottom, instead of minus, put plus. That goes on top and bottom, kind of similar to this old concept. And then all I do is a double FOIL problem right there. So I'm going to go, these two together, these two together. Then I'll get, these two together would be plus 6 root 3. Sometimes people kind of mess that up where they don't realize the 3 needs to get multiplied by this 2. They sometimes will multiply it by this number. Constants go together, roots go together. So then this next one would be 2 root 6. Nothing up top matches, so I can't further simplify that, just like that other problem we just saw. There's going to be something interesting that happens on the bottom, though. 3 times 3 is 9. We then have a 3 root 2 minus 3 root 2. And then minus, that would be root 4, which is the same thing as 2. What is helpful about this process of multiplying the conjugate is these middle terms slash. They will cancel each other out because we set ourselves up with a difference of squares on the bottom. So at the end, we'll say equals -9. I'm just copying down the top. And then all over 7, final answer. So I picked some practice problems for you to try. They are similar. In fact, they are a little easier than the ones I just did. This first one requires just single distribution for the multiplication. It's not the FOIL process. And then this one, you do need a conjugate, but you have a simpler numerator. So that kind of simplifies that process a little bit. Okay, so try them. You can pause the video. I'll show you the answer. Okay, so after you either multiply or divide, you also have to simplify. So these are the completely simplified answers after all is said and done. So I hope this video helped you in some way. I will leave the quote to think about this week. It says, "Rest and be kind. Don't have to prove anything." This is a really nice reminder, especially with ACT prep. Things are a little bit intense, right? It's really nice to just think about, I'm going to try my best. There's nothing I need to prove. I don't have to prove anything to myself, to my family members, to my friends. You just kind of do your best and work hard, though, but the not proving anything, that can be extremely calming to people, to have that thought of not having to achieve this perfection, state of perfection. So I hope you have a great day. Feel free to subscribe if you would like to keep up with more videos, and I'd love to see the answer about your hobbies in the comments. Have a good night.